how you doing? It's Mr. Do the Math, and today we're going to graph linear inequalities. All right, before we dive into inequalities, let's compare equations to inequalities. Right, so when we have the equation 3x plus 1 equals 13 versus 3x plus 1 is less than 13, let's do the math. Let's work it out. So the first thing we do is we subtract 1 to both sides. We'll have, let's just use the black marker. 3x equals 12, right? And then when we divide by 3, we get x equals 4, right? Now when we do the same thing for the less than, we subtract 1, we'll get 3x is less than 12, and when you divide, you get x is less than 4, right? So what's the difference between x being equal to 4 and x being less than 4? Anybody? What do you think? What's the difference? Let's get, yeah, what's up, Amanda?
X
Let's see what she has.
X is equal to 4 in the one, whereas in the other one, X is less than 4, which means that you have to have a smaller number than 4.
Okay. Okay, good. Matthew, what was you gonna say? What was you gonna say? Kind of the same thing? All right, so yeah, like x equals 4 means that's what x is. X is less than 4 means that x can be any number smaller than 4. So it's like, it can be a multitude of numbers. So it's like 3, 2, 1, 0, -1, -2. All of those numbers could be x, right? And so when we graph that in a linear, with a linear inequality, what we're saying is the solution will be the shaded region. So we're going to be shading regions, and we're going to be dealing with like lines being either solid or dashed, depending on the inequality sign, right? So how to show the solution set to a linear inequality? To show the solution to two variable linear inequalities, one must graph the line and shade one side of the line. So basically what we're going to be doing is we're going to be graphing a line, and the solution set would be either this shaded region or that shaded region. And so what we're going to be doing is shading regions once we graph, right? So how to graph? Use the same techniques that we use when we're graphing linear equations, right? So equation goes on that first line, right? So we got two types of lines, right? Two types of lines. We use a solid line for greater than equal to or less than equal to, right? And we use the dashed line for greater than or less than, right? So these make solid lines, and greater than and less than make dashed lines, right? And what that means is the solution set would be if it's greater than or equal to, it will be all of the points on this line plus the shaded region. But for a greater than or less than, it would be all of the points underneath the line not included. That's why it's dashed. Like, that is not a solution. So any point on this line is not a solution set, okay? And so how to shade? You can choose any point that's not on the line and test the point using the equation. So you'll test the point by substituting that value, that x and y value, into the equation, right? And then the statement is true, you shade in that region, underneath the line or above the line. If it's not true, you shade in the opposite region. You shade opposite to the test point, right? So what I'm saying is, if we tested this point here, right? And if it was true, we would shade in this region, right? But then vice versa, if we tested this point and you substituted it in, you substituted in x and y, and it was not true, you would shade in the opposite region, right? And so that's what I'm saying right here when you're testing to see if a point is true or not. So let's do some. Let's talk about it. All right, so we're going to graph this solution set. So we got y is greater than or equal to 2 over 5x plus 3. 2 over 5x plus 3, okay? Again, we're just going to graph this the same way that we would graph a regular linear equation. right? So the first thing we want to do is we want to find our slope and our y-intercept. What's the slope here? 2 over 5, right? That means you're going to go up 2 and to the right 5, right? What's the y-intercept? 3, right? So we're going to apply a point at 0, 3. 1, 2, 3, right? So we got a point here, right? And we're going to go up 2, 1, 2, and to the right 5. 1, 2, 3, 4, 5, right? So we put a point right here. Now, before we draw our line, we need to look at our sign. So because this is greater than or equal to, this is a solid line or a dashed line? So this is a solid line. Since it's a solid line, we'll just connect the dots. Let me see. I'll try to do this without a straight edge. Right. Okay. Now, this is the way shading works. This is the way that shading works. If it's greater than or greater than equal to, you shade above the line, right? If it's less than or less than equal to, you shade under the line. Under the line or behind, right? Behind, if it's like a vertical line, you shade behind. So if it's a vertical line, you shade in front. You shade above or in front of the line if it's greater than. And so now, because this is greater than, we would shade above the line, right? Which means that all the points on this line and above this line will make that true. Okay? So let's see. If this is at 3, right? If this is at y equals 3, and this is 2, we can put a point at, let's say 5. Let's test it. So we put a point at 5. Let's put a point at 5. I'm sorry, not 5. 5. This is 5. Yeah, 5. Let's do 5, 7. 5, 7, right? And we can test that. Let's see what it says. So we have 7. 7 is y, right? And 5 is x. So it'd be 7 is greater than or equal to 2 over 5 times 5 plus 3, right? So 2 over 5, that's going to be 10 over 5, which is what? 2, right? So then it would be 7 is greater than or equal to 2 plus 3. Is 7 greater than or equal to 5? Yes. So that check to be true. Okay? Everybody see what's going on. Do y'all remember this how it's going? Yeah? No? All right. Okay, cool. All right, so that's one example. Let's look at this next example. Let's graph this one. So we had 10x minus 5y is greater than negative 30. Okay? How do you want to graph this? We want to find the x and y intercept? All right, let's find the x and y intercept. I think this Marcus had this today. All right, so the x and y intercept, right? So the x intercept would be what? Negative 3. So look, we'll do 10x is greater than negative 30, right? So then x would be negative 3 when you divide. And then for the negative 5, we got 5y is greater than negative 30, right? Y is greater than 6. So, and this is just for our x and y and stuff. So we got a point at negative 3, 0, and we got a point at 0, 6, right? So let's plot those points. 1, 2, 3, negative 3, and then 1, 2, 3, 4, 5, 6 up here. Right? All right, let's see. And let's see for safety purposes. For safety purposes, let's write this in slope intercept. Okay? So we're going to subtract this 10 over. So we'll have negative 5y is greater than negative 10x minus 30. And then divide by 5. So if we divide by negative 5, it'll be y is and we'll change the direction of this arrow. When I saw that, I realized we probably need to change the direction of the arrow. So it'll be 10 over, so it'll be divided by -5 divided by -5. So that's going to be positive 2x plus 6, right? Positive 2x plus 6. So the equation is y is less than 2x plus 6. Does everybody see that? Okay. We still have our x-intercept there, and our slope is positive. It's going in this direction. All right. Now, because this says less than, we have a dashed line. So we're going to draw a dashed line through this, right? Bop, 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 bop. Dashed line. Now, it says less than. Since it's less than, we're going to shade underneath this line. So your shaded region will be the points underneath that. Okay? Be the points underneath that. Okay? And we can test that by, we can use this point here, we can use the origin, 0, 0. Right? 0, 0. Right? So if y equals 0, and we said x equals 0, let me move it over here. Y equals 0, and x equals 0, so that's 2 times 0 plus 6. When we simplify that, it'll be 0 is less than 6. Is that true? 0 less than 6?
Yes.
Yeah, so it's true. So we did it right. Okay? So I think what we should do is, when equations are in standard form, we should change it to slope-intercept form so that we can see the direction of our inequality sign, right? Because for this one, we had to change the directions, Jaden, of the inequality sign. Okay? So let's see. All right, let's look at number 3. Number 3. What is the difference between the solution sets, right? What's the difference between the solution sets? And I will sketch this out for us, and I'll sketch this out for us so we can look at it. All right. So we got one graph that looks like this. I don't even know why I did that. I didn't have to do that. All right, so it says y equals negative x plus 6. This looks like a question off of our quiz. Y equals negative x plus 6, and so you got a graph that's doing this. And then you got y is less than or equal to negative x plus 6. All right? And so you got the same line, but this shaded region. All right? What's the difference between these two solution sets? Yeah, Jerry. One's an inequality, right? Anything else? What's the difference between these two solution sets? One shaded and it isn't? Okay. All right. What else is the difference? Yeah. So look. So for this one, the solution set is just this line. This is the solution, right? And for this one, the solution is this line and all the lines underneath this line, right? So the solution set here, the solution set is a region here, right? Because it's an inequality. And the solution set here is a line, right? It's just a line, right? So when we're dealing with graphing linear inequalities, we're graphing and we're trying to find the region that will make the inequality or the inequality true. When we're graphing a linear equation, we're just trying to find the line that makes it true, right? So we're trying to find all of these points that make that true, okay? All right, cool. All right, number 5, which of the following order pairs satisfies this equation here? And so for in this SAT question where you have 5x minus 3y is less than 4, right? They want to know which order pairs make it true. And they give you this point, 1, 1. They give you this point, 2, 5. And then they give you this point, 3, 2, right? So in order to figure out the answer here, we would substitute these x and y values into this to see if it's true. these X and Y values and those X and Y values, and that'll be our answer, right? So let's do it, all right? So let's do 1, so that's gonna be 5 times 1 minus 3 times 1 is less than 4. 5 times 1 is 5, minus 3 is less than 4. 5 minus 3 is 2. Is 2 less than 4?
Yeah.
So 1 is 1. Let's do 2 and 5. So that'll be 5 times 2 minus 3 times 5 is less than 4. So that'll be 10 minus 15, right? That'll be, is negative 5 less than 4? Yes. All right. Let's look at the last one. That's going to be 5 times 3. Hold on. Did I do something wrong? Yeah, no. 5 times 3 minus 3 times 2 is less than 4. 5 times 3 is 15 minus 6. 15 minus 6 is what? Is 9 less than 4? No. Right? So then the solution would be 1 and 2. Right? That would be the answer. So whenever they're asking you to figure out what satisfies, they're trying to find what points will fall within the region to make this inequality true. Much like how we tested these two examples here, right? So just to backtrack, just make sure that if you have greater than equal to, less than or equal to, you have a solid line. And if it's greater than, you shade above or in front of the line. Well, for the camera to be above or in front of the line. And then if it's less than or less than equal to, you shade underneath or behind the line. All right? Everybody get what we're saying? Okay, cool. If you haven't already, don't forget to like and subscribe. Until next time, Mr. Do the Math out.